and welcome. I think we are streaming. We are going to find out pretty soon. Oh, come on now. Tweet the things. Okay. So let's go and make sure it shows up correctly on the YouTubes. I think we're also going on Twitch, and yeah, it should be on the correct thing. Yeah, there it goes. Awesome. Okay, and it's alive and kicking. Awesome. All right, so the goal today, we are this is 5 days in. We're on day number 5 of, let me kick it up and start it up. Day number 5 of building a 2D physics game in 2 weeks, with 100% of the development on live stream and 100% of the code being open sourced on GitHub. You can find it, it should be in the description. So here's what we have so far that we've built. We have sticks that you can create, and then they just act like sticks, which is pretty great. We have pistons, and a piston moves back and forth. So let me make a little thing so we can see it. So that's a piston. You see it just goes back and forth, up and down. Pretty good. And we also have engines, and an engine goes back and forth. All right, so you can see a little guy. Oops, you can see a little guy hanging, and it just sends it back and forth, back and forth. We have balloons, and balloons you can attach to, and they float. Let's attach it to that guy. Yes, now those balloons are connected. It's connected to this thing. No, it's not. I missed. I keep missing. Anyway, yeah, you get the idea. There's balloons. Yesterday, we did balloons yesterday. We did wheels. The wheel we did yesterday. So this, we can attach it to that, which is a terrible idea. Yeah, look at that. It goes back and forth. The wheels are a little bit derpy. We're going to try and fix that today. And then you can also move stuff around, so we can pick something up, kind of toss it around in the scene. Pull things down. Yeah, so there we go. So that's kind of what we got. What I would like to do today is I would like to get it, I'd like to fix wheels a little bit, because wheels are a little bit strange still. So one thing I noticed when I played around with it yesterday is if we put the wheel down, if we pick it up, we can spin it, right, which is fine. But if we spin it, once it hits the wall, it actually stops spinning, which isn't quite correct. And I think I know what the bug is that causes that. But see, it just completely stops spinning. So I want to fix that so it spins properly, even when it's bouncing off of walls and things like that. Let me turn my volume down just a little bit. What else are we going to do? The other thought was to make a spring, like a shock absorber, almost like an unpowered piston, where a piston goes back and forth of its own power, back and forth, short and long. I want to make something like that that can do the same kind of thing, but only when under stress, as opposed to all of the time. I think the other thing we did, let me see if I can get it. So here's our piston. If an item breaks, it's not going to break. Are you kidding me? Let's reinforce this maybe. Maybe now it'll break. No, it still doesn't want to break. Man. Maybe we can break along this one. But when it breaks, there's a break animation. Yeah, there it goes. And all the pieces kind of fly off. So that's also kind of fun. So what we want to do today is we want to build. Let's fix wheels first, because I think wheels are going to be pretty easy to fix with any luck. So if we pick it up, we toss it, it's spinning, it hits the wall, it stops spinning. Let's fix that. And then let's also fix, see how when we move it around, it wobbles back and forth. I want to go ahead and put 2 more sticks right here. Nope, go away. Go away, go away. Put 2 more sticks right here. And I think that's going to make it a lot more stable all the time and less derpy. So yeah, so let's do that. Let's do that real quick, because I think that'll just take a few minutes. That'll get us off to a nice start. Let's go to the wheel. Let me show you where this code is too. Code physics. There it is. It's on screen. There's the GitHub repo. It should be in the description as well. So everything I'm working on is on there, and I'll push up to it during the stream. Let's go to the wheel. So here are 2 crossbars. We got 3 crossbars. This one is, I think this guy is the, yeah, between 2 and 3. And so we need 2 more of these guys. So we're going to have a 4 and a 5, right? Because we have, oh my goodness, here's our wheel, right? So we have 1 right there, 1 right there, and 1 right there, I believe. So I think that's right. Yeah. Yeah, you can see one of the crossbars there. So anyway, we need another one. So let's do another one right here. 4 and 5, and that's P0 and P2. I think we want P0 and P1 and P2 and P3. I believe. Let's see what that looks like. We need to tick them. 4, 5. Crossbar, we're going to constrain those. I'm going to pull this out, because that was trying to keep things constrained, and it didn't really do what we wanted. 4 and 5. All right, I think that's all that we need. Let's try it. Okay, so here's our wheel. No, that's not what we need. We have, oh, maybe in the, let's pull this out. There we go. All right, so the points are different than I thought they were. So P0 and P1 are plus or minus X. P2 and P3 are plus or minus Y. So we want P0 shouldn't go to P1. Right here, P0 goes to P2, and P0 needs to go to P3. And they each need to go to each. That was the issue. There we go. That should be what we want. Yep. Yes, except no. Oh. 2, 3, 4, 5. Yes, except yes, because I can't name things correctly. Awesome. So here we go. Now we have our wheel, which is reinforced much better than it used to be, which is good. So we have 2 of those. We can put a piston Oh, come on. I always mess up the piston wheel. Maybe we'll fix that today too, where the gesture doesn't always begin where it thinks it's going to. And it stopped, and now we can do that maybe? What is that going to do? That's ridiculous. Okay, great. Great. That's awesome. All right, cool. Cool. Git commit. We're going to do reinforced wheels. Right, so now that's up there. You can check that out if you want. What was the other thing we were going to do? We're going to fix the rotation. That's what we want to do. And so where did we do that? We did that in... did we do it in here? We added constrain wheels. That's where it was. Yeah. Excuse me. Okay, so constrain wheels. What we're doing is, as I recall, yep, great. Still working. So as I recall, what we were doing to constrain the wheels, as it hit the wall, the velocity, we're looking at the center point if it's within a radius distance of the wall, and if it is, we're flipping the velocity of that center point along that x-axis, right, which is fine. We also flip the velocity of all the other points along the x-axis, and what I think we're doing is we're actually just hard coding the velocity of those 4 points to match the center point, but when they're spinning like that, they're obviously not, they sum to the same thing, but individually they're not the same thing. So when we hit the wall, we need to, that was interesting. We need to add the center point's velocity to each endpoint instead of just setting it on itself, right? So let's do, maybe we'll comment this a little bit better too. Okay, so move x, this is basically the delta x, the delta vx, I think, is what we can, what we could probably call it. Vx times bounce. Yeah, so I think what we'll do, delta Vx, like that. That's our change in velocity. Equals that, right? And then that way we can, when we're mucking around with the points down here, for the other 4 points, we can use that delta V, as well as how much we offset it, right? Because we have to, let me show you this makes sense. So let's make a new wheel. So when we move the point, when we move the thing to the edge, it thinks the point is actually already too close, so we have to re-offset it to be away from the wall and also change its velocity, so the next frame it will start moving away. So there's 2 pieces to it. There's the offset and then there's the velocity change. So we've been using the offset, which is great, and now we're going to track the velocity change here. So delta Vx, right? And now we want delta Y, whoops, delta Vy. There we go. And then that's actually just going to be the same here, right? So now we have, if we actually need to do anything, great. And then here's the problem. Here but these two things, the difference between px and old x is the velocity. And so what we need to do is we need to add the velocity of here, right? So we want v dot x plus equal delta vx to delta vy. I think that's all we need to do. So that way the velocity is what it used to be, plus the velocity change of the center point. It might be completely wrong. I might be thinking about this wrong. Delta v, because this is the velocity of the point. Yeah, I think that's what we want, and I think actually delta v, this already handles bounce, so we want that, because this already tracks that bounce percentage here, right? So this handles the bounce. This takes what its current velocity is relative to the center point, adds the velocity change of the center point, and then updates its old position to match that, right? I think that's right. This is probably going to go terribly wrong. Let's find out. That bounced a surprising amount. Now we have infinite energy. That's amazing. Vx. Maybe we do need to multiply it by bounce. And I was wrong. Because those velocities will still be, yeah, that's really bad. This is what it was. This is the velocity of the point, velocity for friction minus old x. Yep. So this is it moving into the wall. Okay, this is it moving into the wall. This sets its old point inside of the wall, so that way it starts moving away from the wall. This shows velocity going towards the wall, right? So P0, 1, 2, and 3. They all move the exact same amount that they used to. Their velocity is what their velocity used to be. What their relative velocity towards the wall used to be, because now we're reversing it. Yeah, this is actually, I feel like this was right, so why are they stopping? Let's just not update their velocities and see what happens. Yeah, so what happens there is it's like lead, right? Because the center point wants to bounce. So it bounces just a little bit, but the other guys, oops. But the other guys are still going, are still trying to go down. But it keeps rotating correctly, which it doesn't do if we add the bounce, right? If we add the bounce, it bounces, which is good. But doesn't, but completely stops rotating. So yeah, I thought, So we move Y. Let's stop it there and see what things actually look like. So we have to move the Y 15 pixels up, and that's just to adjust it, right? So that just slides everything up a little bit, but keeps the velocity the exact same. So now the move Y needs to be 5 pixels, so it's going to move everything up by 5 pixels. Its velocity is going down by 20 pixels. So when it bounces, we actually want the, what was the velocity change of the center point? The center point velocity change, the delta V. Sorry, add expression. Delta Vy is 18, so it should still be going down by 3 is what we want, right? Because relative to the center point, it's moving by 3 pixels, and we want to maintain that even after the bounce. And so after the bounce, it is going to be going yeah, so now the old Y what is happening here? Until quit. Deny. Delta Vy. I think that's the guy that we want, because this is going to adjust everything backwards. Actually, I think we might want that. I think we're onto something. So we want the y moves up, the old y moves up. The old y we actually want to be this, because this is going to reverse. That reverses its velocity. And then we want to add on to it the difference in velocity between v dot y minus delta v dot y, because this is the center point's velocity, this is its velocity. Yeah, I feel like that's closer to what we want. This section here reverses the direction, and this maintains relative velocity between it and the center point. I think that's what we want. Does that look right? Nope. What happened there? There we go. Hey, look at that. We did it. Now when it bounces, it keeps its rotation. That's what we want. We did it. Vx, Vx, and delta Vx. Alright, so this is going to reverse velocity of the point, maintain relative, let's spell that correctly. Right? That makes sense. I like that. Now we've got wheels that can maintain their spinning. Yeah, that's awesome. Cool. Wheels maintain spin when hitting walls. That looks right to me. Okay, so this a wheel is a stick. So this constrain wheels business, where do we do that? We constrain wheels after we constrain sticks. I think that's okay. If S is not a wheel, there we go. Now we're going to take this code. This code should really not be here. That doesn't make any sense. Oops, I don't want to do the entire for loop and everything. I just want this part. Yes, great. And we're going to put this inside of the wheel class because it really belongs in there in its constrain method. Right? Oh, maybe I can't. Because wheels are treated like points Yeah. And can't clean that up. Okay, that's fine. We'll just put it back. Not the most beautiful thing to put it there, but that's okay. So the other issue that I found yesterday was let's make a little box. Oops, let's turn the animation off. Let's make a little box right here. There we go. And if we make a balloon, great. So those do what we think they're going to do. But if I move this balloon, come here. If I move this balloon and I drop it on there to connect it to the box, it acts like it's connected, but then when I turn on the animation, oh no, wait, I'm sorry, I did it wrong. I did it backwards. If I move the box and put it onto the balloon, like that, it's going to act like it connects, except it doesn't, because this balloon is no longer there. It's dead. And the reason that balloon is dead is because balloons currently extend points, and when we replace points, we replace them with whatever. If we replace a balloon point, we just replace it with a regular point, which is bad. So we need to not do that. So what we need to do instead is we need to, I believe, change balloons to be kind of stick objects of sorts, like machine objects, instead of point objects. I think that's the best way to do it. Let's look here. If when we create a balloon, we add it to points and we add it to balloons. So I think what we want to do instead is sticks have the replace point with point. I think we want to do the same thing here, and sticks just extend NSObject. Yeah. I think that's what we want to do also. If we extend it by NSObject instead of point, and now we can have a property, which will be a point called the center of the balloon. There we go. And then we're going to synthesize that. Awesome. .center.x. Okay, there we go. So that's how we create it, which is fine. Here, we're going to update with gravity, and we're going to render it. Self.center. Awesome, I like that. And then here, balloon.center. Let's see if that gets us what we want. This is a balloon. So the balloon needs to be called a balloon. Thank you very much. We're going to add a render method to it. Let's make that public. What else do we have? Oh, is that it? Great. So now we need to replace point. So where is that guy? Right here. And here, if P, oops, is our center, then center is new P. That's pretty much it. Great. So now we need to figure out where we call replace point and make sure we call it on all of our balloons. Is that the only place we call it? It is. It is. It is. Balloons. We go balloon. We just need to replace it, and then it will just work. So now I think we're okay. Now I think we can drag. Let's make sure we can still create balloons. What happens here? Balloon.center is nil. We never created one, right? Yep, we did not. So we need to do, oops. Center, just an empty point. There we go. So now it's an object. Balloons should be able to collide. I like that idea. You can have, that is definitely not going the right way. It is bouncing down. Yeah, I like that idea. Update with gravity. We never call update with gravity on this guy. Oops, make a balloon. No, we don't. It's because we're calling it with on the point object. So how do we want to handle that? Because we used to, since balloon used to extend point, it used to override this method to handle gravity. But now, since we don't extend point, then we can't do that, right? So a couple thoughts. We could add a delegate to the point, and so that way whenever the balloon creates a point or replaces the point, it sets itself as the delegate to adjust what gravity is. I think what I want to do instead is have a property here that's just a block. Let's see if I can do that correctly. This is actually going to be a CG float, and it's going to accept a CG float. Gravity modifier. Can we do that? Property requires fields to be named. Maybe I put it here. Look at me with my amazing block syntax. Okay. So now when we update with gravity, if we have one, then we can do. Can we do that? Oh yeah, then we need to synthesize it. Arc forbids synthesizing property with unspecified ownership. So does that mean we need to define this ourselves? Existing instance variable must be unsafe unretained, but we do want to retain it. Why can I not retain it? Okay, well, let's not synthesize it then. We are going to do this. We're going to do this the hard way. How do you do the how do you do a setter for that? How do you return a block? This is, oh, CG float. Float. That is the ugliest thing in the world. Is that a thing? Can we do it? Yeah, there we go. And block syntax is the worst. Okay, so now if we have one, then we can adjust the gravity, right? So now, when a balloon makes a point, center.gravity modifier, we just reverse gravity, which feels pretty good. And then when we, if we ever have to swap the point with something else, I like that. I think that's a fine way to do it. Perfectly fine. Okay. Let's do this, and then we can, hello, extra worst. Let's do this, and then we can try to make balloons collide. There we go. So now it goes correctly. So now the other thing, see it bounces right on the edge. I want it to bounce. I would like balloons to bounce off the edge just like wheels do, right? Where it's the outer rim of the balloon. I think that'd be nice. But let's go ahead and commit this. Fixed balloons getting their point stolen, basically, right? Let's also verify that that fixes what we think it fixes. So that now we should be able to drop this guy, yeah. And he kind of floats down, which is cool. And we can put another one right there, and now our block is floating. It's awesome. Great. Can we make it actually float even higher? Look at that. Have a ridiculous tail on it, like a kite. That is silly. Cool. All right, so that code is up. You can download it right there. It's in the description, so y'all can play around with it. So now let's get balloons colliding off of the edge of the screen, and then we'll see if we can extend it to collide against each other as well, right? So they push each other away. And then that will let us do cool things where we have like have lots of balloons, right? In a little pack. And then instead of these all overlapping each other, when I hit the go button, they'll all kind of bounce off of each other, which I think would be pretty neat. That's going to be a little more complicated. Not too bad, because we just need to, we'll calculate the offset of the centers to figure out what vector they should be, so they bounce off at the right vector, right? Yeah, anyway, we'll deal with that in a minute. Let's fix it, the balloons bouncing off of the edge first. And then we can fix them to bounce off of the rest of the stuff. So let's do constrain. I think that's in constraint points. This is the guy that bounces off of the edge. So let's add another one called constrain balloons. There we go. B.center. Let's just update these so they're pointing at the right thing. I should have just done I don't know if you can actually rename with a property. So this will be good. This will actually be interesting too, because we can use balloons as like for heavy objects as little round feet. Right, like if we made this guy, can we make him heavier? So he starts falling. Yeah. And so then that's ridiculous. Anyway, you get what I'm pointing. We can put balloons on the bottom of the device of whatever our little machine is. Okay, so if we have balloons, we want to actually let's look at wheels, because we're going to steal a lot of the same logic, the wheel radius. So balloons, I think, are hard-coded for a radius right now. Yeah, radius of 25. So let's change that. Let's make that a property so we can have balloons of different sizes. Float radius. And then we can even, like later on, we can make balloons that change radius size randomly or with different things. I think that would be cool. Okay, so now we have a radius, and our radius is 25. Great. So now we need, yeah, we actually just need to steal like this idea, right? Where we adjust based on the radius. Constrain balloons. Okay. This is b.radius. Oops. b.radius minus b.radius. There we go. And if it's less than here. So now what I think we want to do is in our render, we want to make sure we constrain wheels, and we want to constrain balloons before we constrain points, right? And the reason for that is because we're checking if things are processed or not. And so we can process the balloon before we process the points, and then when we process points, it will just skip over the balloon centers. There we go. So now we can go to here, and now it should bounce off of its, yep, you can see it bounces off of its edge, which is great. Come on, let me grab it. Let me grab it. Let me grab it. Here we go. Oh, I grabbed it and I didn't. Put him right there. Put another one right here. Awesome. And then if I flip it over, bonk, it lands on its little balloon feet. Awesome. Cool. Floating boxes. Balloons hit the edge. Right. Now the next thing is if we're going to do balloons colliding with each other. That will be the next. So let's do. I think that'll be okay. So this is make sure balloon is inside the box. Make sure the balloon isn't hitting other balloons. And we're going to do that down here. Right? So now we're going to go through do we use I anywhere else? We can just do, right? Yeah. Other balloon. We only care about it if it's not itself. So we want the distance between them is the other balloon's center from our balloon, right? And if that distance is less than the other guy's radius plus our radius, then we have a collision, right? And so now we need to figure out how much to move and which direction to move each of the things. So the movement is going to be the distance. It's going to be the other radiuses minus the distance, right? So if that is greater than 0, if I need to move the balloons apart, right? Then this is how much I move them. And so then we need the vector along which to move them, right? Let's do vector equals CG point make. Other, not radius, center dot x minus b dot center dot as dot x. That is really ugly. Let's make a helper method real quick. Make sure I don't already have one. Let's do, we're going to call this difference from some other point, right? And this is going to be in CG point terms. There we go. Now we can take this guy and put him in here, just to keep things a little bit cleaner. There we go. I think we're going to be using this in a couple different places. There we go. I like it. Okay, so now we can calculate the difference between 2 points. Let's go back here. So now this is going to be a little bit easier. Except I need to add it to, did I not add it to here? Yeah, I did. It's just not auto-completing. Oh, it's because I do center difference from p dot center. Okay. B dot center. Thank you. Okay, so now we can do, each one is going to move only half of the distance. X plus equals vector x divided by 2. Vector y divided by 2. And then the other guy is going to move the opposite direction. Right? And we need to make sure their velocities don't change, I think. Go. Except I need to do that. Wait, no. I had it right. Bold Y. There we go. So I think that lets us collide balloons. I'm pretty sure. Let's find out what happens. Make a balloon. Great. If I make another balloon, they become the same thing. So I think I'm doing these backwards, maybe. Let's just see real quick. I'm just going to swap them so that way they go the other direction. There we go. Yeah, I do need to change the velocity though, because they're bouncing really weird. They're bouncing really weird. I might need to make an animation step method as well, so we can go in slow motion and see what's happening a little bit better. Oh my goodness, that was amazing. Explosive pinball balloons. Okay, these are the distance. Oh, you know what I need to do actually? Because the radiuses are I think that's part of the problem. So we're adjusting we're detecting when the borders hit, and then we're asking the balloons to be their radius distance apart as well. And I don't think that's what we want. So the difference from what's our distance here? Our distance is 46. So we only actually need to move them 3.5 pixels. We don't need to move them. Yeah. We don't need to move them. And we're actually moving them like 50 pixels right now. So that's part of the problem. So let's fix that. So the vector needs to be basically normalized to 3.5. Right? So vector.x equals distance divided by vector.x. Isn't this how you normalize, I think? Maybe. I feel like that's better anyway. It's pretty good. And they're definitely going crazy sometimes, which I don't entirely understand yet. I think we do need to add the old X as well. So that way their velocity stays the same. Instead of being, if they're going really slow and they're suddenly moved by 3 pixels, then it's basically, they basically just sped up because of the collision, and that doesn't make any sense. Ooh. Yep. And it's also, yeah, and that speed up makes it infinite. Okay. There we go. Let's fix that and just fix our signs. Clean up our code a little bit. There we go. So now our velocities should not change, even though the balloons get pushed away from each other. Definitely some weird stuff still happening. Let's fix that. Carry vector because our distance is 21. So is this guy returning? That guy should not be returning infinite. It would only be infinite if distance is a number and the vector x is 0. Oh, okay. We just want it to not equal 0. Otherwise, stay 0. Not equal 0. Otherwise, stay 0. Yeah, I don't think I'm not normalizing correctly. I think this is actually backwards. Is anybody good at vector math? They do get pushed away. They don't bounce. They don't bounce entirely off of each other. They kind of push away slowly. Which maybe that's an okay dynamic, I guess. But I'd really like them to come to rest on top so you could kind of stack them up. And to do that, I think we need to do the same thing we do with the walls, where we actually reverse their velocity a little bit. No, even then. Nope. No, we got something wrong. So they're 40 pixels apart. We want them to be 50 pixels apart. Our distance is 50. Our vector is 50. Our movement is 10. I think that's what I did wrong. Yeah, because otherwise our vector is going to be 0, and we want our vector to be like no. Here's what we want. We are normalizing on distance. That's fine. And then after we're normalized, we want to, that's what we want to do. Pretty sure. Balloon. So now here, our vector is 39, right? Which is fine. So we want it to be like basically base of x and y. So now it's going to be between 0 and 1, which is fine. And we want to figure out who needs to move, or which direction we need to move 10 pixels. So now we need to move mostly in the y direction 10 pixels and a little bit in the x, which is great. So now we update both of our directions. B dot center, this guy should be on the top, x, y 209, and the other B needs to be x, y 249. Yeah, so this guy's going to go down, and the other guy's going to go up. Yeah. Now they actually, now they're colliding the correct way. That's awesome. That's what we want. That looks really good. So it's clear. So now we can make our little, our little thing of balloons. Balloons. 1, 2, 3, 4, 5, 6. This guy needs to go right there. This guy is immovable. Move them, and then let's put a balloon here. We'll put a balloon here. Put a balloon over here. And over here. Oops. And over there. That's pretty great. Even here we can push them around. There we go. Look at that. Our little balloons. That's great. Maybe when they hit, we need to slow them down too, because they should not be perpetual machining like that. Maybe when they hit, we I think when we hit, we average their velocities. That would be a good way to do it. Balloons collide. Oops. Awesome. I like it. I do not have a physics background. I have a computer science background. So I've done a lot of math, but I don't have lots of physics or anything. This is honestly my first game. So it's not that I'm into 2D games versus 3D games versus any other kind of games. It's that I've really never made a game. So this is my first one. I figured it'd be a fun experiment. So now we want to average their velocities, right? So this is going to be the collision fix their offset to be outside their combined radius. Now we want to average their velocities. So what would that look like? They would both end up going the same direction, right? So we want, do we have a b-dot velocity? No, we don't. Let's make a convenience method on point. Oh, we have velocity for friction. Okay, great. So if we want CG point VB is going to be the B dot center velocity for friction, and we're just going to have 0 friction because we're just going to average them together. The friction was already taken care of earlier, I believe, right? Anyway, we're not going to deal with friction here, is the answer. The other B. The other B, velocity for friction. Great. Average velocity is going to be VB.x plus V other.x divided by 2. And this is going to be VB.y plus V other.y, oops, divided by 2. Right? So now we want B.center yeah, we're actually just going to be overriding all of these old x's and old y's. Equals B.center.x plus average velocity.x. Old y is equal to the y plus that, right? And this is going to be other. Great. I think that's all we need to average the velocities together. Let's go to, that's what we want. Okay. That's not quite what I expected, to be honest. All right, so maybe instead what we want to do that really did not work at all like I wanted. So what if instead we just slowed their velocity? Right? What if we did that? Oh, I want B, other B. What if we did that? Because that way they keep their same velocity, but they just start going slower because of the bounce. But they keep their same direction. That didn't work either. Good heavens. Nope. Put a breakpoint and see what's going on and what we want to happen. So what we want to happen is this guy was going up, this guy was going down. We want them to kind of bounce off each other, but just a little bit. So let's look at what our vector x Okay, so this is what I think we want to do. Is the old x minus the movement, but we have ignored what its velocity used to be. So we need to take that into account. I'm pretty sure that way the velocity is adjusted by how much it just moved plus how much it was moving, right? So it's just kind of like a little bump to change its velocity vector. And this is actually going to be not minus equals, but it's going to be that minus the I think that's what we want. We'll set a breakpoint in here to confirm. Right, so that way, here it is with its old velocity, but also adjusted by this guy. That guy used to be a plus, so he needs a plus, right? I think that's what we want. Nope. Okay, so let's set our breakpoint. Let's clear everything. Okay, so our breakpoint's up. So there's our balloon. He's going up. This guy is going down. So the amount of movement is 10 pixels in the y direction and just a little bit in the x direction. So VB it thinks is not moving. V other B it thinks is not moving. Why does it think that? Because they should be, these guys should be moving. Let's try again, because those velocities are not. Oh, you know what? This is, yeah, friction. Huh. Okay, that's part of the problem. It's still a problem. here. So one is moving slowly downwards. The guy who's colliding is moving much quicker downwards. So the difference, this is their distance from each other, so mostly in the y direction, which is correct. So the distance they need to move apart is in vector, right? We're going to show distance. That way we can actually name things something meaningful instead of something not even remotely meaningful. So we move them apart, that's fine. What we might do is we might he moves, distance move apart, he moves backwards by, what is this? Oh, he was called vector a minute ago. By 5 pixels. Right? We're just gonna, instead of trying to recalculate a velocity here, we're going to just update their velocity vector, so that way we can track the changes here, which I think is going to make a lot more sense. Alright, so the other guy gets the plus, this guy gets the minus, so I did those backwards. Minus. There we go. There we go. There we go. And now let's run it. I think we're going to need a I'm going to put these next to each other just so it looks a little bit cleaner. I think we're probably still going to need a breakpoint because some of my signs might be wrong. Alright, so VB is 10. Distance to move apart is just a measly 3 pixels. There we go. So we're going to move, this guy should move there we go, their velocity changes a little bit. Honestly, not sure why we need to update its old location, because we're just moving it slightly to the side. I think I was way overthinking it as part of the problem. Because now look at it. Now it's actually acting like we think it should. Yeah. I don't know why I was overthinking it. That was way easier than it should have been. My goodness. Bink. So that means we don't even need to calculate these velocities because we don't use them. We just move the points. We're gonna rename this to be something a little bit shorter. Dist moved. Dist to move, how about that? Shorter variable names, that way we're not writing paragraphs. Yeah, that's fine. Oh, yeah. There we go. So now let's turn the animation off, and I think we can now create our little balloon thing. So now if I move this balloon, oops, come here. This guy and this guy. And this guy and this guy. That guy. That guy. And then this is going to be movable. Did it act? Yeah, it acts perfectly fine. Man, I don't know what we did last time, but this is that was way easier than it should have been. Way harder than it should have been, because we did stuff we really shouldn't have bothered with. Balloons collide correctly. Right? Awesome. Cool. Yeah, whoever's idea that was a great idea. It just took me way too long to build, but we did it. I did it. That guy, and then we can move him. Oops. Move him. That's great. That's so rewarding. Okay, cool. Bonk. Lift the box. Awesome. Okay, what was the other thing we wanted to do? There's more stuff. I want to see if we can fix the pan gesture, because it's really annoying to start a line and it starts it in a different place than we thought it did. Pan gesture delay. Is that going to bring up anything? Not what I want. UI pan gesture recognizer. It's what do we call it? There's an initial translation. That's exactly the problem I'm having. Yeah. Where it's sometimes, yeah, 10 or 15 pixels off. moved enough to be considered a pan. This is what we're gonna do. We're gonna have to make our own subclass. That's okay. That's actually a pretty easy fix. Let's do that real quick. Gesture. We're gonna call it instant pan gesture recognizer. Hopefully I spelled that right, because that's what we're going with. This is import UI kit, and this is UI gesture recognizer subclass. Touches moved, super, touches moved, event, and then self.state equal to UI gesture recognizer state changed. There we go. And now in our physics view, we're going to use this gesture instead of the pan gesture. Recognizer. Yeah, there we go. So now it should always start at the point we think it should start on. Oh, there's still a delay, unless I'm really bad at mousing, which I might be. No, I mean, there's still... You know, I think we're going to make it... I think it's because of the move, and if I move too far... If that very first movement is... we're going to make it literally instant, not just on the first move. I think that's what we want. So now it should always, even when we move, man, see? It's better. I don't know if it's fixed or not. I might just not be mousing very good. Crash. And now we can't click that because the gesture steals it. Alright, so that's not what we want. Maybe we have to do it on moved. I think we probably have to. Now we can do that, and we can still pretty good. Actually, this just began. You know what we can do also? This is a bit of a cop out, but I'd rather have it be always accurate than not. Read only an initial point in view. Initial location in window is what we'll call it. There we go, and then void touches began. Super touches began. Self location view. Here we go. What's wrong with that? That's probably what's wrong with that. All right, awesome. Initial location and view. So we do instant pan gesture. UI gesture state. Oops, there we go. Where it began. Curloc equals pan gesture dot. What do we call it? Yeah, initial location and window. Oops. Right. Go. And that's a tap gesture. This is a tap gesture. This is a pan gesture. Instant. And then this is a pan gesture. So this way, even if the gesture starts late, we get the very first point on the screen that they cared about. Yeah, that's better. Cool. Awesome. I like it. Fixed initial touch of pan gestures to always be accurate. Awesome, I like it. Okay, so my next thought is possibly make a spring to make another entity type that we can create. So a piston I don't know if you can see that. A piston contracts. Right? A piston contracts like that. I would like to make another object that's basically like a piston except unpowered. So that way it can stretch back and forth. I think it'll be pretty easy to make too. So let's just do that and see how far we get with it. This is going to be a, we're going to call it a, oops, not a sprint. We're going to call it a spring. Right. So it's going to have very similar methods to here. Spring with P0. We're going to save our initial length. Oh wait, our initial length is already saved in super.length right here. Right? So our tick, we don't actually need to tick at all because we don't have an angle. So what this guy does is this guy changes its length based on the angle, and instead we want to change our length based on basically on our stress, right? Yeah, and this stress calculation is okay. That's perfectly fine. So our spring, this is our full length is length, right? Our current length is our P0 how do we points have a distance method, right? Yeah, distance from point. That's what I want. I want this guy. P1, that was the deal. Okay, so here's our current length. So we have, if we wanted to go from 1 is fully extended, so our ratio is our current divided by our full, right? It is normal. 1.2 is, we'll say, fully stretched. 1.2 and 0.8 are fully stretched. So we say if ratio is less than 0.8, then yeah, right, yeah, sorry. This is the ideal length. Okay. We might actually need to do this in the constrain method. Yeah. Yeah. Yeah, with P0. Yeah, with P0. There we go. So always return the ideal length. That's fine. So now this is where we want to do it. This is where we want to change our ideal length, is in the tick method. Can I call super length here? I think I can. Initial length. Cannot spell length for the life of me. Current length. Self.p0, distance from, self.p1. Right? And so now, because the thought is, here's my thought. So I make the stick that long. If it's compressed to be this long, then on the tick method, I want to update it. Sorry, I want to update it so that way its ideal length is actually this long, just a little bit taller. And then every tick, it's going to get a little bit closer and a little bit closer to its initial height until it gets back, right? So the shorter it is, the faster I want to move it back to its initial length. That's what I want to do. So angle doesn't make any sense. So CG float, the diff is the initial minus the current, right? So now if I'm too short, this is going to be a positive number. So now we want current plus equal, we'll say this is going to be the springiness times the diff. And our springiness is going to be 0.8. We're going to make it 0.5. It's going to go half the distance back every time. Ideal length. There we go. I think that's what we want. So now let's make one. Let's just make it whenever we create a piston, let's just create a spring instead, just to see if things work, and then we'll update the interface once everything's said and done. So create piston. Oops, we need to include the file. Import and then spring. There we go. And then when we create the piston here, spring with P0. Give it a method. So now I think that means we just made a spring. I think. So let's test it. Let's make a box like this. This is our spring, even though it says piston. That did not make any sense. That is obviously wrong. Okay, let's do that again. And we'll put a breakpoint in tick, because somehow its ideal length was set to 0, which is not what we want. Yeah, still having a hard time. Yeah, its ideal length is 0. Alright, so if I make another one, oops. Super. That is why. Now my ideal length is 180. Great. Make this guy here. We're going to do some cross beams of some springs. And we're going to turn it on, and it should wobble vertically, but not necessarily side to side, because these two things should keep it side to side. That did not really do anything. Still too rigid, so let's make our springiness only 5% closer instead of half a distance closer. Much less springy. Box made out of springs. Nothing. Yeah, I think we do. I think the constrain method of the stick is yeah, it is. Let's give us a new constrain method. So our length is ideal length. This is the distance they currently are. This is the distance they're allowed to be. I really don't understand why that's not updating. That should be... I mean, it is changing, but it's changing so small. I think the problem is in constrain. I don't think we need tick. I don't think we need length. I think we only need to mess around with constrain. Dx dy. So yeah, so if we do springiness of 1%, right, dx, and now the springiness is only sorry, here we want the difference to only care about springiness. So then our stress we're not going to care about stress right now. Stress is just going to be 0. No stress on the spring. We'll fix stress later. There we go. That's what we want. Okay, so now if we make a box out of springs, it will wobble around. That's awesome. That's what we want. That looks great. That looks great. Great, great, great. Okay, so now our stress, we actually do need to put a stress on this. Maybe tighten up the spring a little bit. So our stick, this is our stress. We want to save that here. Our stress can be accessed by subclasses. There we go. All right. So our ideal length and self.calclen no, because that's after the update. So we want, let's put this down here. So float. twice. So now it should have stress as well. Yep. And the stress of the spring is percent difference between its actual length and its ideal length, so the percent difference. If the percent difference is, yeah, I think we want that because we want it way less stressed than a stick. We want it to handle a lot more stress than a stick. Yeah, there we go. And it balanced. That was amazing. So let's put it times 5 so it can handle twice as much stress as a stick. Let's see what that does. Nope. Nope. Let's do that. 5 times as much stress as a stick. There we go. Yeah, you can see it. You can see it turn just a little bit purple, right? That's good. Yeah, now you can see him turn just a little bit purple when it's doing the work. So now as it gets stretched out between those two things. That is silly. Engine, up, up, facing the same direction. And then make a piston between these and stick, like that. Go, and if we stretch the spring between those, yeah, you see it gets stretched good, which is good. And if we did the same thing, with a stick, I think the stick would break. I think it might not. It might have a no. It forces the engine, which is interesting. I think if we made the stick first and then the engines, I really don't understand what's happening. There we go. I would have thought it would have been, that stick should be under a lot of stress right there. Anyways, let's fix the interface. Create spring gesture. Pretty good. We're going to put it right inside of here. Oops. Create spring gesture. Great. Very good job. So now in between the piston and the engine, right inside of here, we're going to put the spring. gesture. 2, 3, 4, 5, 6. Okay. There we go. And now the create piston gesture. There we go. This is now called create spring gesture. And then here we put this back to the piston. So I think we can create all of them. So if I make pistons with some sticks, and a piston, and a piston, and a stick, and a stick, and a stick, and come on now. Create spring gesture. I should have done that. Let's try again. Okay, so now we create our base right here. That. Create some pistons here. Pistons here. Springs here. It is springy. Pretty great. Yeah, it stretches a lot more. Maybe we'll make it stretch even more later. I feel like it could or should or would have been even more stretchy than it is, but that's okay. Still pretty good. Okay, cool. Springs. Awesome. We got all kinds of stuff now that we can end up playing with. I have no idea what just happened there. What have we done? We broke wheels. When did we break wheels? I'm very confused. I'm not aware of why or when that would have happened. So they're fine right there. Maybe it was when balloons got there. Let's just look real quick, because this should be an easy thing to track down. Yeah, that was the commit. Must have been the gravity modifier. Is that when we did it? It's either the gravity modifier or what else would it be? We had balloon centers. This is balloons. This is update sticks. It must have been here. Yeah. I think we never call that. Right? Is that my problem? We used to call that and then we updated it to constrain wheels. We didn't. Yep, that was it. Easy fix. Yep. Fixed wheels. Oops. There we go. Now we have piston. So now when we run, we should have wheels and springs. So here's a spring. Here's piston. There we go. That looks pretty good. I like it. Cool. Cool. That's fun. We're all up to date. There we go. If you want to look at the code, there is the repository. You can download it and play around with it. What I would actually like to do pretty soon is get the build up on iTunes and start having test flight releases so that we can send builds out. Because the goal of this is to not only build a game in 2 weeks, but to submit it to the App Store in 2 weeks. So that's the big thing that we're pushing towards. Today was day 5, I believe, if I'm counting correctly. So we got 9 days left. So we're a third of the way through. So what I would like is if we can get this version into iTunes, and then people who want to can sign up with their email, and we can start sending builds out, which I think would be cool, and we can all play with it and make ideas and suggestions, and slowly get it into the store, which I think would be really cool to do. Anyways, check out, there's a website. I just set it up today. It has a little bit of live stream info. It has a mailing list. It has stuff. It's just a place to collect ideas and to collect some thoughts. So check that out. It should be in the description. It's sparepartsapp.com. Spare Parts I thought would be a really cool name. I love the balloons. I think that whoever's idea it was to make them collide, I think that was right on. I think that's really fun. So I think Spare Parts kind of is a good name for this because it's just a bunch of stuff, and you can just make contraptions and little machines and kind of ridiculousness. I think it's great. I think that's the goal. So yeah, check out the website. Sign up for the email. When I do get the test flight stuff set up, so we can all get early demos of it before we submit in 9 days, I'll ping there and we can sign up there. And yeah, if you have ideas on what we should do, what we should make. Last night I started looking for sound effects that we could use. And I found a couple. I'll try to, on this website, I'm going to try to put up some blog posts and some ideas there. But I found a couple sound effects. I'm trying to think about what we want to do for the art style and for what things should actually look like. So thoughts there would be much appreciated on what we can do for art and what we can do for sounds. I have a couple ideas for what the interface can be. I think these buttons and stuff, this is fine just to test, but I would like something a little bit easier to use. So maybe next time we'll play with some different interface ideas on different ways we can make it look. But some of that will also depend on the art style. So anyway, if you have any thoughts on that, that would be awesome. Code is open source, so if you want to pull it down and play with it, make suggestions or thoughts, you can do that too. I am going to call it for today. That was a little bit over 2 hours. I think we were really productive. We made springs. We fixed wheels, so now when a wheel is thrown up against the wall, it continues to spin, which is a good thing. Whee! It spins properly, so that's really good. What else do we do? We did balloons and balloon collisions. We fixed some stuff there, which is awesome. We did springs, so now we have springs. I think we're all set up to have like really, really cool, to start building cool, really interesting machines. We have like, we can make a wheel, we can make a spring, and a spring, and a stick, and a stick, and a stick, and oops. Let's see if we can make like a really like rudimentary car suspension system. All right, and then a spring, and a spring. What is that going to do? Yeah, now we have a car with suspension. That's great. And if we make if we put an engine inside of here somehow, and we give it a spring from here to like here, what is that going to do? That is not going to do anything. That's going to break all the things. Anyway, I think we can make like some pretty interesting little contraptions now. I think we have a lot of stuff to work with. So anyway, so next time let's work on maybe the interface a little bit, maybe bugs or any suggestions that come up between now and then, and maybe sounds if we can find some good sounds. But anyway, that's it for today. Thanks guys for hanging out, and hit me up on Twitter. It's in the description, or look at the website and sign up for the mailing list there, and we can all start talking. Anyways, thanks guys.